Hello. So my name's Sam Erickson. I'm here to talk to you a little bit about drone imagery processing. Basically, I want to talk to you about how you might fit drones into your GIS and remote sensing workflow. I'm going to go into like a very high level overview of what drone processing entails, what photogrammetry is in the drone processing world, and what kind of steps you might take to get into drones in general and planning missions. And yeah, I think we'll just have a little bit of fun with it on the high level side and not dig too deep into the processing, but just know that just about anybody can get into this relatively easily with just a little bit of research and not that much funding, actually. So I just wanted to tell you a little bit about myself before we get too deep into this. I got my start at when I took a remote sensing course a few years ago at Cuesta, taught by Faraday Schroeder, and then I transferred to Cal Poly and got in touch with Dr. Andrew Fricker, who lined me up with his P4 multispectral drone, which I flew in aid of the Morro Bay eelgrass monitoring program. And then I lined up with Kyle Nesson at Althouse and Mead and worked under him as an intern for a while, doing a variety of really cool projects and flying this slant range multispectral you see in the center of this slide. And that's loaded on a DJI M200 drone. And then last summer I worked for UC Davis under Derek Young, camping all summer and capturing imagery in aid of a conifer seedling dispersal project. And then now I'm back at Althouse and Mead as their remote sensing analyst. And then in my free time I just like to go outside and hike and have fun around the Central Coast, and I'm always bringing my dog you see up in the right hand corner there, Theo, and he is, as you can see, a goofy dog. So one of your first questions is probably going to be, what benefits do I get from including this new technology into my GIS or remote sensing workflow? Like, why would I go through the steps to include drones in what might already be a well-established workflow? For one, you get super high resolution ortho imagery from your drone missions. I'm talking on the scale of 5 centimeters or 2 inches per pixel squared spatial resolution. You also get a temporal resolution of whatever you want. There's no more waiting for a satellite to come by and then hope that there's no clouds around that are going to block that imagery. Now you just go back out to the field and refly the same area, and you can conduct your change detection or whatever you may be planning on conducting from that repeated imagery. You also end up with a digital elevation model output, which you could also combine with that change detection to maybe do like volumetric calculations for changes in elevation. And I've seen that done at like mills for figuring out what volume of wood fiber exists in an area. That's one use for those DEMs, but also any number of uses that you already use DEMs for in your workflow. You can also end up with super dense point clouds from this process. One of the first things we should probably do before getting into drone imagery processing is define a very important term, and that's photogrammetry. I put the technical definition on this slide. I'm not going to read it to you, but from a basic standpoint, as far as GIS goes, it is deriving measurements or analysis from visual or otherwise, even outside of the visual spectrum, imagery. It was actually based on like the principles of perspective and projective geometry that, of course, of all the people, Leonardo da Vinci was the creator of. And the term itself was, if you're into history, coined by a Prussian architect, Albert Meydenbauer, in 1867. We know what photogrammetry is from a general perspective now, and how do we conduct photogrammetry? Well, in the 20th century, we might attach a camera to a pigeon or a dove, and then have it take pictures at an interval, and then stitch those images together, find points that match on a light table, stitch them together, and create an ortho image. It'd be a very long, tedious job, but that was what a photogrammetrist did manually. But in recent decades, we've had advances in computer science, including a couple of algorithms that are notable for this process called structure from motion and multi-view stereo. These are the algorithms that are employed automatically, so you don't need to know those necessarily, but they're employed automatically by the software I'm going to tell you later when you're processing your imagery. And so it becomes a much easier workflow. You're not manually stitching images together. All of this happens in one process, and you get all of these outputs. Stitching, matching points through images can give you those 3D models, the point cloud, the DEM, but it also gives you that super high resolution, spatially accurate ortho image as well. So the start of any photogrammetric processing is to capture the imagery. This can be one of the most lengthy parts of the process, actually, just because you have to go out to the field and capture the imagery. I'm not going to go over it in too much depth because there's a lot of specifics that are going to be dependent on your setup. For example, the software that you use when mission planning is going to be almost completely dependent on what drone you get. And so I can't really cover too much on that. You'll have to do some research on your own. Some drones are capable, some are not. But one thing that you're going to find with any mission planning software is that there's a lot of adjustable parameters. And the most important one to start with is going to be overlap, and it's going to be the only one I'm really going to cover right now just because of how important it is. Overlap tells you how many images will cover one single area on the ground. You can see the top right of my slide here, and off to the bottom right are two images that kind of display how overlap works. Basically, you need to have many images covering one location so that software can find these tie points that it will use to stitch together the images. You went out to the field, you captured all this overlapping imagery, you had a good time flying the drone around, and now you've got all these sometimes thousands of images that are taking up quite a bit of space, and they're not really usable in their current form. They are georeferenced, but they're still not really, they're not ortho-corrected. So you need to run them through a software to conduct that photogrammetry we were talking about earlier on it. So there's a few different softwares to choose from. ODM, or Web ODM, which ODM stands for Open Drone Map, is your free and open source software for conducting photogrammetry. It's really well made. The free version is a command line interface utility that's pretty easy to use. You can do multispectral processing, it's node compatible, and you get highly active forum support online where they have people who are the creators and contributors to WebODM actually helping other people out with their data sets and processing. And then for $49 you can get access to their GUI, which you can see in the top right corner. It's very nicely made and it works really well. And then there's Agisoft Metashape. This one has a license. It's $179 for the standard license and $3,499 for the Pro license. The Pro license includes things like multispectral processing and Python scripting, so you can automate different tasks. There's lots of different customizable parameters, and they have a highly active forum just like ODM for support, and you also get support with your purchase as well. It's also notable that they have academic pricing that is very good, so that's something to look into if you're in academia. And then there's a couple of other softwares out there that are pretty well known. Drone to Map was picked up by Esri and can be run right in Arc Pro. I don't have a lot of experience with it myself. And then Pix4D is widely used, and I've heard good things about it. I also don't have a lot of experience with that one. But they have even a cloud processing setup where you can process on their servers, and then you don't pay for anything until you download the output. So you can actually visualize your outputs on their server and decide if they're what you want before you pay for it, which is a nice feature. Okay, now if I had more time, I'd go over the whole process from start to finish, putting in all of your imagery into one of those softwares, what parameters you might use. But a lot of that information can be sourced directly on their websites, and there's some really good sources on there. Actually, I believe both WebODM and Agisoft have created short online instructional booklets that can help you understand what the parameters do. And also, a lot of the times you can get away with the defaults depending on the data set you're using. So instead of going deep into that, I'll let you do that on your own. And I'm just going to talk about some of the examples of outputs you could end up with. Here in the top middle, we flew a redwood stand. This was my friend Orrin Nardi up at College of the Redwoods, flew a redwood stand just off campus. And then we took and used Delaney triangulation and a cloth simulation filter, I know, buzzwords, to create a DTM, a digital terrain model, which we then subtracted from the original point cloud to create a canopy height model, and then rasterize that to create your traditional rasterized canopy height model you see in the bottom right corner there. Another thing you could do from that point, this is a different project. I believe this is eucalyptus stand that I was working on. You can conduct an individual tree detection on this, and you can segment out your point cloud or your raster to get the approximate areas that each individual tree takes up, or the canopy of each individual tree takes up. And another neat and a little more advanced thing you can do here is you can actually segment up your point cloud by elevation, which you can see in the bottom left I've done. And here I cut a point cloud from, I believe it was 3 to 6 foot above the ground. And you can see these little circles. It almost looks like abstract art, but these circles are actually the stems of trees. And because the canopy wasn't too dense, I was able to get a dense enough point cloud to get those stem circles, and then you can do something called a hue transformation to get stem points from that point cloud, which is... Well, all those examples were kind of tree related or nature related. There's certainly analysis and work to be conducted outside of nature using drones. And one of the most prevalent places drones are being used right now is in construction and project management. You can see in this top right corner, you can use a drone to fly a project repeatedly, get the DEMs, and then calculate fill and excavation volumes, as I mentioned earlier. And also, this is a really cool use. Once you've constructed a building, or if you needed to get measurement of the inside of a building or some sort of model of the inside of the building, a lot of people are flying the outside of a building to make a 3D model of the outside, and then additionally taking a drone and then flying it inside of the building, and then combining those to create 3D models both inside and outside of the building. Those are just some of the more complex uses outside of natural resources and biology. Well, thanks for following along with me. I hope I got you a little excited about the possibilities of drones, and maybe go out and find out where they might fit into your own workflows. It's relatively easy to start. It's a lot of fun. There's a lot of different utilities you can use it for. And generally speaking, the minimum barriers to entry aren't that great. There's cheap software. Drones aren't terribly expensive on the lower end, and you can often get away with default settings, so even the knowledge base barriers to entries aren't incredible. So I hope maybe I've convinced you to do a little more research on it, or maybe even take on drones into your own processes. But either way, thanks for following along with me, and have a great GIS day.